Good morning, students. In this video, we are going to see about the procedure of Newton-Raphson method of load flow studies. Kindly go through the video as it is an important university question. Thank you.
Then the variables or the correction vector will consist of voltage magnitude and the voltage angle, because we wish to determine the solution of the system in which we wish to determine mod V and delta. So let us see how we apply the Newton-Raphson to the power flow solution. Now Pi is actually a function of mod V and delta, and Qi is also a function of mod Vi and delta I. Okay, so what we will do is correction vector will be given as delta delta or delta mod V. Jacobian will be given as del P by del delta, del P by del mod V, del Q by del delta, del Q by del mod V. This will be the Jacobian of the system. And your mismatch vector will be P supposed minus calculated, Q supposed minus Q calculated. It actually indicates error, or it is called as mismatch vector. Mismatch means what is the difference between the supposed value and the calculated value. Now if we wish to determine the calculated value, this is also represented as J1, J2, J3, J4, just for shorthand. Now if we wish to determine the correction vector, what we will do is we will take the inverse of Jacobian. So that means P supposed minus P calculated, Q supposed minus Q calculated into J1, J2, J3, J4 inverse is equal to actually delta delta and delta mod V. So that way we obtain what should be the change in the value of delta and the mod V, and then we will update the values of delta and mod V for the new values. As we keep on updating, we will go closer and closer to the actual result. Now let me take a system where I have n buses, out of which one will be slack bus. I am assuming m are the number of PV buses. Then what is the number of PQ buses? N minus m minus 1 will be PQ bus. Remember, slack bus is also a generator bus. So if you are given a 10 generator bus, you will extract one slack bus, then 9 will be treated as PV buses. Now in PQ bus we need to update to the value of mod V as well as delta, but in PV bus we need to update only delta. So delta delta will have the unit of how much? Delta delta will be n minus 1, because we want to update it for n minus 1. And delta mod V, that will be n minus m minus 1, because we do not wish to update for the PV buses.
जय हिंद, नमस्ते। मेरा नाम है ब्रिगेडियर CS विद्यासागर। महिमा सागर मेरा पोती है। 2 साल तक मेरा पोती।
Now Jacobian J1 is actually del P by del delta. Now P is known for all the buses, okay, because PV and PQ would know the P. So it is known for n minus 1 bus. Delta delta is to be updated for n minus 1 bus. So order is n minus 1 cross n minus 1. J2 is del P by del mod V. Now P is known for n minus 1 buses, and mod V we need to calculate for n minus m minus 1 buses. Now J3, del Q by del delta. Q is known for only n minus m minus 1 buses. Delta is known for n minus 1 buses. Del Q by del mod V. Q is only known for n minus m minus 1 buses, and we wish to calculate mod V for n minus m minus 1 buses. So from here we can see J1 and J4 are square matrices. Okay, and what is the order of Jacobian? Here J1 has n minus 1 rows, n minus 1 column. J2 has n minus 1 rows and n minus m minus 1. This has n minus m minus 1 and n minus 1 column, n minus m minus 1 cross n minus m minus 1. So what is total number of rows? N minus 1 plus n minus m minus 1, that is 2n minus m minus 2. What is the total number of column? N minus 1 plus n minus m minus 1. So this is the order of Jacobian. That is 2n minus m minus 2 cross 2n minus m minus 2. The easier way to remember this is, instead of just remembering the formula, we need delta for mod V for PV buses and mod V and mod delta for PQ buses. So that means we will need two equations for PQ bus and one for PV bus. So this is the order of Jacobian. Okay, that is an easier way to remember the order of Jacobian in terms of number of PQ buses and the PV buses. Okay. Now, if suppose we wish to calculate the correction vector, then we will have to take the inverse of Jacobian. Now, if Jacobian is a singular matrix, then its inverse would be 0. That means the correction vector cannot be determined and system is thus said to be unstable. If mod j is 0, system is unstable. Okay, whenever the determinant is 0. Okay, now let us take an example. It is saying a 100 bus power system network has bus 1 as the slack bus. Okay, then we are left with 99 buses, out of which 20 are PV buses. So PV are 20 and remaining are PQ, which is equal to del P by del delta. Now equation of Pi as we derived earlier was J is equal to 0 to 1 to n mod Vi mod Vj mod Yij cos of delta j minus delta I plus theta ij. Now let me separate the ith term from here. J is equal to 1 to n. J is not equal to I mod Vi mod Vj mod Yij cos of delta I minus delta I plus theta ij. And if I is equal to j, then the term would be mod Vi square Yii, delta I and delta j will get cancelled out. Now if we calculate del Pi by del delta I, that is the diagonal elements of J1, then it will become, the derivative of first term would be sigma j is equal to 1 to n, j is not equal to I, derivative of cos is minus sign and minus sign will become plus sign, mod Vi mod Vj mod Yij sine of delta j minus delta I plus theta ij. Derivative of this term would be 0. So now if we wish to write it in a more compact form, this form resembles Qi. So I will write how much it will become, minus Qi and minus mod Vi square mod Yij sine theta ii. How I have written it is, I have added and subtracted this term so that this condition goes away. J is not equal to I. If you add this term, then this condition will go away and this will become minus Qi. So that is how we have arrived at the diagonal element. if we wish to derive the non-diagonal element, that is del pi by del delta j, then this summation will go away because we are differentiating for a particular value of delta j. It will become mod vi mod vj mod sigma j is equal to 1 to n, j is not equal to I, mod vi mod vj mod yij cos of delta j minus delta I plus theta ij plus mod of vi square yii cos of theta ii. Now if we calculate the diagonal elements, that is del p by del mod vi, then this term would become sigma j is equal to 1 to n, j is not equal to I, mod vj mod yij cos of delta j minus delta I plus theta ij. Derivative of second term would be 2 mod vi mod yii cos theta ii. Now multiply and divide by mod vi, or multiply both sides by mod vi. So it will become j is equal to 1 to n, j is not equal to I, mod vi mod vj mod yij cos of delta j minus delta I plus theta ij plus 2 mod vi square mod yii cos theta ii. Now this expression is same as p, just there is an additional term 2. So this can be written as pi plus mod vi square mod yii cos theta ii. So that is how this can be written as a more compact type of form. Now if we wish to calculate the off diagonal element, because this is a matrix, so it will have diagonal as well as off diagonal elements, then we will calculate del pi by del of q, j is equal to 1 to n. Let me separate the ith term, mod vi mod vj mod yij sine of delta j minus delta I plus theta ij minus mod vi square mod yii sine of theta ii. Now if we wish to calculate diagonal element del qi by del delta I, so this will be minus j is equal to 1 to n, j is not equal to I, then sine derivative will be cos, so it will become plus cos of delta j minus delta I plus theta ij. Then the derivative of this term would be 0. Now this term resembles power, but the j is not equal to I, so we will add the ith term and subtract the ith term. So that is mod vi square mod yii cos theta ii. We have added and subtracted this term, so it can be expressed in terms of pi. Okay, so that is a more compact type of form. Now if we wish to calculate the off diagonal element, then del qi minus summation j is equal to 1 to n, j is not equal to I, mod vi mod vj mod yij sine of delta j minus delta I plus theta ij minus mod vi square yii sine of theta ii. Now if we want to find diagonal element del q by del mod vi, then it will be minus j is equal to 1 to n, j is not equal to I, mod vj mod yij sine of delta j minus delta I plus theta ij minus 2 mod vi yi sine theta I. Now this term appears like the initial term, but here one. So what we can write is delta p delta q is actually, we can write like this: j1 j2 mod v, j3 j4 mod v. Why I am multiplying it by mod v? Because here I will take delta v by mod v. As you saw, the elements that we calculated, del q by del mod v, here also we took mod v, and mod v into del p by del mod v. So that way the elements became compact, and hence we will use it something like this. Okay, this can also be written as H N J L. That is, we have given these matrices a name, that is H N J and L. Now let us see what are the steps to be followed when we are solving a problem using Newton-Raphson. So the step 1 remains the same in all the methods. We have to take Y bus matrix. Now if n is the number of buses and 2 up to m are PV buses, then m plus 1, m plus 2 up to n will be PQ buses, and bus 1 will be slack. Here we will set iteration count as 0 and tolerance as 0.0001. Okay, so here only we will set the iteration count and tolerance. Now in step 2, we assume some values. So for PQ buses, we assume Vi is equal to 1 angle 0, that is for all I belonging to m plus 1 up to n. And for PV buses, we assume only delta I is equal to 0 for all I 2 up to m. Okay, so that means delta I assumed as 0 for PV as well as PQ buses, but mod Vi is taken as 1 only for the PQ buses. Now we will calculate Pi and Qi for all I is equal to, Pi can be calculated at all the buses PV as well as PQ. So Pi will be calculated for all I 2 up to n, but Qi can only be calculated at PQ buses. So I m plus 1 up to n. Okay, that is your Pi calculated. Now we will calculate the mismatch vector in the next step, that is delta P and delta Q. Delta P will be P supposed minus calculated. Okay, delta Pi, and similarly delta Qi will be Qi supposed minus Qi calculated. So this delta Pi can be calculated for all buses 2 up to n. For PV as well as PQ, this can be calculated only for PQ buses, that is m plus 1 up to n. Okay, then we get a mismatch vector, that is delta P and delta Q. Now the next step should be finding the Jacobian. So here we find the matrix, that is the modified form of Jacobian H, N, J and L. We will determine this matrix in step number 5. In step number 6, what we will do is, we will determine the correction vector, that is delta mod V by mod V, which will be H N J L inverse into delta P delta Q. That way we will calculate the correction vector. Now we know that we have to update mod V only for PQ buses and mod delta for PV buses. So we will update delta for PV plus PQ buses, mod V only for PQ buses. Okay, then we again calculate Pi and Qi for all I 2, 3 up to n, and we check if generator Qi lies between QGI min and QGI max. If it does not lie within this limit, what we will do is we will convert a PV bus to a PQ bus and then again repeat the initial steps. Okay. And if it still lies in this limit, then PV bus will be treated as PV bus for the future steps. So then what we will do is we will again calculate delta Pi, that is Pi supposed minus calculated. So we again get the mismatch vector. Now we will check that if maximum of delta Pi is less than epsilon and maximum of delta Qi is less than epsilon, then the load flow solution converges. That is, there is no mismatch. If it is not if it does not occur, then what we will do is we will go and repeat the entire process. So we will go on iterating until we get a condition where the maximum of the mismatch vector is less than epsilon. The next method is
So in this video, we saw about the Newton-Raphson method of finding the solution of load flow studies. We will see a problem on this topic in the next class. Thank you.